In this video, I'm going to be talking about what a vector is, how to use something called the tip-to-tail method, and how to find the solution to just about any vector problem. So first of all, what is a vector? A vector is basically an arrow with a number attached to it. So something that has a magnitude, okay, which is basically its numerical value, and something that has a direction. The direction is shown with an arrow or in words such as right or left or north or south. Now, the way you're going to add them is something called the tip-to-tail method, which is basically saying at the tip of one arrow or the tip of one vector is where the next one starts. And then the resultant is the final sum of the vectors. So it's taking a point that is the very beginning of your first arrow to the tip of your very last one. So I'll show you three simple examples, and then I'll do one that's a little bit more complicated. So here is a basic example of two different vectors. It would be something maybe like a bike traveling 5 meters per second to the right, and then it has wind blowing to the right as well at 2 meters per second. So then you would have your first vector, and then you would connect your second vector tip to tail. So here's the tip, and then the tail is the beginning of the next one, and that one is 2. Your final answer is always going to be an arrow that starts at the beginning and then goes all the way to the tip of the last one. So that's just 5 plus 2. So it would be 7 meters per second. Okay, so you would say that is the resultant. And if you're talking about some, say, for example, velocities, you could say that's the resultant velocity or final velocity, overall velocity, something along those lines. All right, for the next one, it's going to be a similar idea. We are going to have a 5 meter per second vector going to the right, and then we're going to start the second vector where the first one ends, which will take us back this way too. And then what we get is a final resultant vector from beginning to the end, which is basically just 5 minus 2, so it's going to be 3 meters per second. And finally, our last one. Our last one is the one that gets slightly more complex, and we have a vector that goes over 5, and it goes up 2. When you connect the starting point to the ending point, you get that angled component. So what you would do is you'd use the Pythagorean theorem, which is a squared plus b squared equals c squared. So a and b are just two sides of a right triangle, and then c is going to be the hypotenuse of the triangle. So this would basically be your c. So what you would do is you would take a squared, which would just be either of these two sides, plus b squared, and that equals c squared. Okay, so 2 squared is 4, 5 squared is 25. Okay, and that would mean that c squared is 29, and then you would finish by finding the square root of both sides. Okay, so that is our final version of it. And then a more complex version that you would use in math or physics is having angled components and combining angled components with either straight vertical or horizontal components. So what I'm going to do is I'm going to show you how to break down both of these angled vectors and how to combine them to get a final solution as far as how long the vector is, and then also which direction it's pointing. So the first step I normally do is I usually just redraw the vector and then make it into a right triangle. So I'm going to grab my blue one over here. It is going up and over 8. And then what I'm going to do is I'm going to close it off into a right triangle. So I'm going to go over to the right and then up. And then what I'm going to do is I'm going to solve for what's called the x and y components, or the horizontal and vertical components. So I'll call this x, and then I'll call this one y. Okay, so how you solve for that is you would use sine and cosine. You would use a combination of different trig functions, and we want to use sine and cosine because both of those involve the hypotenuse, and we do have the hypotenuse of our triangle. So the sine of 30 degrees is opposite, so the opposite end is our y over the hypotenuse, which is 8. And then for the x component, we're going to use cosine, so the cosine of 30 degrees is equal to the adjacent side, so the side that's right beside it, that's definitely not opposite of it, and it's definitely not the hypotenuse, the longest side of our triangle. So that is x and then over the hypotenuse. So what you would do for both of them is you would basically just multiply both sides by 8, and that would give us our answer. So if we do 8 times sine of 30, that's going to give us 4. So I'm going to add that over here actually. So here's my y component, which is 4. And then I'm going to take cosine of 30 degrees times 8, and that's going to give me about 6.93. Okay, so there's my x and y component. So I'm going to do the same exact thing with my red triangle over here, except I'm going to replace the 30 degrees with the 20 degrees, and I'm going to replace these two 8s with the 10, and it'll look something like this. All right, so I went ahead and basically did a similar process for my red vector over here. It's going downwards to the left, and again, I use sine to find my y component, and then I use cosine to find my x component the same way I did up here, and I got 9.40 for my x component, and then 3.42 for my y component. Okay, so what we're going to do is we're going to make both of these into a single right triangle. So we used some skills before to do the tip to tail method, and we're going to do the tip to tail method 3 different times. Okay, what you have to do is you have to analyze the x component, which is the horizontal component. So we have both of these, which is 6.93 going to the right, and then we have 9.4 going to the left, which means that our final answer is from here to here. Okay, so if you take 9.40 and then you subtract 6.93, you get an answer of 2.47 for this horizontal vector. We're going to do the same thing in the y direction. We're going to take a look at our 2 vertical components, and we have 4 going upwards, and then we have 3.42 coming back down. And then our answer is going to be this tiny little upward vector. And when we take 4 minus 3.42, we have 0.58. All right, so that's the method. So the first thing we did was we just found the x and y component of both of our right triangles. Okay, this one happens to have like 2 of each, but it could be 3 of each or 4 of each, whatever the case is. It's basically adding or subtracting to some degree. As long as you use the tip to tail method, you'll be able to accurately solve for your components. So I said we're going to use a tip to tail method 3 times. So this was the first time for our x component, the second time for our y component, and then finally we're going to use it to put together our final right triangle. So for our final right triangle, we have 2.47 horizontal to the left. And then we also have 0.58. That one is going slightly upwards. And then our final answer would be this vector, the hypotenuse of this right triangle. So we did a version of that before using the Pythagorean theorem. So we're going to do the same sort of thing. We're going to take a squared plus b squared and then set that equal to c squared, this final one over here. So we can go ahead and call that c. So let's go ahead and do the Pythagorean theorem and figure out what that hypotenuse is. So we did the same thing as before. We took both of our sides that weren't the hypotenuse, squared both of them, added them up, and then we square rooted both sides to get our answer, and we got an answer of 2.54. So that gives us our final value for our vector. And one more thing you may need to solve for is the angle at which it's pointing. So we can go ahead and solve for the angle right here. And anytime you have angles and a side, then you just use trig functions to find other sides. Anytime you have sides and you want an angle, what you do is use inverse trig functions. So we could use inverse sine, inverse cosine, or inverse of tangent. Any of those are fine. I'm just going to choose to use the inverse of tangent. Okay, but any of those three would work. Okay, so tangent is the TOA for our SOHCAHTOA, which is opposite over our adjacent. And when you do the inverse sine of that fraction, you get 13.21 degrees. Okay, so our final answer for this pretty long and complex problem is the vector, the resultant vector is 2.54 going 13.21 degrees. And what you can do is to add some detail on top of that. You could talk about that two different ways. You might just put that 13.21 in your diagram, but depending on how the question is written, you might write something like this: 13.21 degrees north of west. Okay, and the reason why I said north of west is because west is going to be basically to the left, and then north is tilted upwards from there, so it's tilting up 13.21 degrees north of west. So providing that final detail of north of west would be a final detail that you may need to add because you don't know if that 13.21 degrees is some different angle. Is it the angle above this vector? Is it going to be the one below it? You're not quite sure unless you add this final detail to it. So I hope that was helpful in helping you understand what a vector is and how to solve variations of all different types of problems. Thank you for watching and listening.